G'day, I'm Ms.Witt. Today we're building a vacuum cannon. This vacuum cannon has two chambers, the high pressure chamber and the low pressure chamber, also known as a vacuum. The difference in pressures causes a great amount of energy, which can be used to propel our projectile, also known as a ping-pong ball, at a very high speed. If we can create a big enough difference in pressure using enough layers of foil so they don't break as easily, we can propel our projectile past Mach 1 at supersonic. We can use gauges to measure the PSI and the pressurized in the vacuum chamber. We can then use that ratio and compare it to the speed of the projectile to figure out how the difference in particles affects the speed of a projectile in a vacuum cannon. Time for the real science. G'day, mate.
Slip.
1, 2, Chad. Two sheets of foil. You're talking in the background, so everyone's here.
Everybody knows what's going on.
Loading it for 4 sheets. Should be good. $2:33, 6 hours till school starts. Oh, g'day. Now you've seen our vacuum cannon fire, time to do some math. By using 2 microphones, we were able to measure how fast the ball travelled 5 feet. The slowest ball took 9 thousandths of a second, and the quickest took 4.6 thousandths of a second. We then calculated how fast this would be in miles per hour, and found that the quickest ball went 741 miles per hour, which is 20 miles per hour away from being from breaking the sound barrier. We then calculated the number of particles in the vacuum and pressure chambers. For the vacuum chamber, our pump maxed out at 26 psi below atmospheric pressure, so we were able to use that as a constant in the calculations. To calculate the number of particles in the pressurized chamber, we use the equation PV over NT. We plugged in our pressures from each test to find the number of moles in each test, I guess. For a test at 2 sheets, we had a pressure of around 14 psi above atmospheric pressure. For a test with 3 sheets of foil, we had pressures around 29 psi. For 4 sheets of foil, we had staggering pressures of 43.5 psi. Break it!
5:36 and we're done.